Hello, welcome to HTH 2021 CTF Solve Video Series. I'm John, and we're going to be taking a look at the second opponentable challenge. What is the name of it? Echo Control. All right, so for Echo Control, we're going to have to do something to manipulate this application opponent and figure out what the flag is. So let's go ahead and do that. I have this particular challenge set up in Ghidra already, and I've already done a couple namings of the variables here. These end up being generic names like local 8, local 10, or whatever else. But let's interact with the application. So in the CTF, it tells you this is the location where you can actually interact with this. Just use netcat to get to this port, this IP. So when we do that, it's going to ask us for a command. When we type in a command, it'll tell us about the command. So we got to go find the command and figure out what's going on here. Okay. So first of all, one of the things I notice is when I load this is that it's actually reading something called flag.txt. It's going to put that into this file stream here, this file descriptor is going to be reading 3F bytes. 3F is going to be 63 bytes from this file and placing it into the flag buffer, which is a stack-based buffer, and it's going to null it out. So memset, this is going to initialize this or declare this, and then this is going to actually set it. Make sure that if anything is on the stack at that point, it just nulls it out with 0. And it's going to do that for 40, which will end up being 64 bytes of just nulls. Here it's ready to accept whatever is in this particular flag file and place it here. Next thing we do is at the end of this, we'll just null terminate that string. In case it's longer, it'll just truncate it at 63 bytes, and the 64th byte will just be a null byte. So as we keep going down here, it's going to print out some information to us. It's going to get up to 64 bytes for a command. Once this command is accepted from the user, it's going to strip off the new line or carriage return, set a null byte at the end, and then it's going to check to see if it's check flag. If it's check flag, it will continue to do some extra stuff. So let's go ahead and try that to make sure that works okay. So we'll do this, and then it was check flag. We'll do that. Now it asks us for the flag. So if I type in some information, what should be interesting here is this gets echoed out, which is just an artifact from the challenge. And the way that we launch it, it says wrong flag, and then you'll have this information here followed by disconnect. So this is interesting. Anytime that you enter something into an application, so my name is John, I'll put this here, John disconnected. Anytime an application spits back what you fed to it, should raise sort of red flags, or at least make you think, how are they handling that data? Because what's happening is data that you are presenting to it is being somehow affected and printed back out to you. And we want to make sure that that's being sanitized and escaped properly. So there's one potential problem that could be there. And that's one of the things that I think about when I see that. So let's continue on and just see what else we're getting here. All right, so we're going to get our flag input. The flag input, once it asks us for a flag, it's actually going to take up to 256 bytes. So that's quite a bit.
Are you done?
No, I'm not done. So it's going to take up to 256 bytes. And then from there, it's going to remove the new lines, exactly like we said, null terminate it. It's going to take the length of our flag, which we read in from the file earlier. And then it's going to use that to do a stir and comparison. So again, we can add as much information as we need to in here because it's only going to check the amount of bytes that the flag actually is against our user input. From there, if that comparison was exactly correct, it'll tell us you got the flag and print out the flag. Otherwise, it tells us wrong flag and it just prints back our user input. So what's wrong here is that, well, the challenge here is that we actually need to give it the correct flag in order to know that we got the correct flag. So we don't know how large this particular flag is. We know that it's up to 63 bytes because we do need that null terminator at the end, which will take up 1 byte. So if we need 63 bytes, we have to essentially try to guess a 63 character combination, which is going to be just basically impossible. So what we need to do is try to figure out what the trick is here to this. And the trick is whatever input I give it, it's going to spit back out. The problem with a function like printf or format string functions are when you give it something that doesn't already have a parameterized input. So the way that printf is supposed to work is I give it a string like literal string hello and then %s. And then I put comma, and then I put a variable, which is a pointer to another string that may hold John. So it would print hello, John. If it takes only one input, that first input, if it's user controlled, is not parameterized. So actually, I can actually enter like %x, and what will happen is once printf runs and it sees that little string %x, which is my input, it's going to go, oh, you want the first thing on the stack, and it will pop data off the stack and give it to you. So what can happen here is I can just keep giving it %s or %x and popping hex data off of the stack, and I can do this up to 256 bytes worth of data or 255 bytes worth of data. And if I do this, then very likely what I'll be able to do is print out so much of the stack that I actually print out the flag which exists on the stack. Up here, when the application prints or reads flag, it reads it into this buffer, which exists on the stack. So we want to keep doing this until we end up printing off that flag. Now, there is a flag format in the CTF that starts with capital H, capital T, capital H, and then curly braces around the flag. So we should be able to see the first indication that we're at the flag and the end indication that we're at the end of the flag. So let's go ahead and see how this will work. First, we're going to verify that what we think is correct by doing the %x stuff. So the command, again, is check flag. I'm going to do something like %x, and it's going to say wrong flag, but it gave us data. So that data came directly from the stack. This is a 64-bit binary. So we're going to use LX for long, and that's going to be, instead of 4 bytes, 8 bytes. So we're going to do this a little bit differently. What I want to do is just go ahead and take the payload that I already have constructed here just to make this video a little bit faster. So what we're going to end up doing is we're going to send the payload. So Python 3 -c means command line script. So I'm just going to literally feed it a script in one line. So we're going to do print. I'll give it the literal check flag with a new line. So that enters check flag, presses the new line. And then we're going to do add on more to that, which is going to be %lx with a dot in the middle, so we can see, it's easier to see the delineation between these things, because we might have to end up actually flipping them. And we're going to do that 80 times. We're just going to shotgun a whole bunch out there, spill a bunch of stuff from the stack, and then see if we can sort through it and figure out what's going on here. Okay, so let's throw that. And what we end up seeing, I'll bring this up to the top of my screen, is it'll tell us wrong flag, puts out those 8 bytes plus the dot, 8 bytes. It doesn't pad it out to the full length, it's just 0. And then continues to do this. So anytime we see a dot is a separator between that slot on the stack. So the stack is basically that %f just said, oh, okay, you want me to print 8 bytes from the stack? Boom, 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 and it kept doing it. And the %x formats 4 bytes as hex. %lx will format 8 bytes as hex. We could also do %s, but if it's not a string or it hits a character that is null, it'll stop that output. So this is really the best way to do this. So as I'm looking at this, I know that EF isn't a valid hex character. And the way to do this, or a valid ASCII hex character, let's go ASCII table. Let me see if I can find a good one here. This one's decent. Okay. So really what we're looking for is we're looking for HTH, and we're also looking for the curly braces. So those curly braces are 7D, and where is the other one here? All right, I feel like I'm going crazy. Oh, 7B. So 7D and 7B are two things that we sort of want to look for. We also want to look for the HTH. So 48, 54, 48. So let's see if we can find anything that looks like this. This looks like it could potentially be a block of hex characters. So I like this. 72 was one of the things, I think, right? No, it's 7A or 7B and 7D. Let's see what this looks like, 7A and 7D. What I could do is just copy this. I'll open it up a hex editor that I have, ONO, which is a great hex editor. And then I'll do edit, paste from hex text. We can kind of see it here. It comes out a little bit. but it's a little mangled. So let's see, HTH, what we have to do is take each one of those sections and flip them. So I am looking for the other half of this thing here. All of this can go away, that's junk. All of this can go away, that's junk. So 1, 2, really 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I think we want to do this in 8 byte chunks. I'm not sure why some of this data seemed to have gotten messed up. So let's check this out. Let's go to Sublime Text. And what I'll do is copy this data out. We'll see if we can do it in 8 byte chunks. 1, 2, 3, 4, 5, 6, 7, 8. This. All right, let's flip this. So HTH, YOUR underscore CT STA ACK underscore IS. So you see what I'm doing? I'm starting over here like this, and I'm working my way this way, and then working my way this way to flip those 8 byte chunks that I have here. So it's YOUR underscore STACK underscore IS underscore show SHOWING. And then something here starts to get messed up. And it turns out this is the actual flag. Let's try running this again and seeing maybe if we just had some oddity in this particular run. Wonder where that sort of issue came from. So let me copy all of this.
Approximately 10 hours later.
We're only missing, it seems complete. So adding this extra little bit isn't the hugest leap, but I think that's kind of a unfortunate thing. It's not the way I would ideally like to have a problem set up, but this is the way that you solve it. The whole trick here is basically we can control how much information we pop from the stack and basically ask it to give us that information, right? So I hope that kind of made sense, and we'll see you in the next video. Thanks.